when pyruvate enters the mitochondria, it's a 3-carbon molecule, and the Krebs cycle cannot take a 3-carbon molecule entering it. It has to have a 2-carbon molecule. So as soon as pyruvate enters the mitochondria, it's going to go through what we call a transition reaction. And this transition reaction breaks pyruvate down into a 2-carbon molecule. So this reaction gives us a 2-carbon molecule called acetyl-CoA. So we break the carbon off, we add a coenzyme A, and we get acetyl-CoA. And in that transition reaction, we get from it, we get 2 NADHs. So here's an NADH here, and we get 2, because remember there are 2 pyruvate. Okay, so with each of them going through this, we get 2 NADHs. We also lose some carbon dioxide. 2 of them, as a matter of fact. So once we go through this, we get our little electron carriers, because we broke apart some carbon, so we got some electrons, and we get this thing called acetyl-CoA. Acetyl-CoA will enter the Krebs cycle, and the Krebs cycle is a cycle of chemical reactions. And I'm not going to ask you to know all the chemical reactions that occur around this Krebs cycle, but I do want you to know when the acetyl-CoA comes into the Krebs cycle. So just put Krebs cycle here. It goes in and it links onto a molecule. And that molecule is called oxaloacetate, or OAA. So oxaloacetate. And oxaloacetate is a 4-carbon molecule. And when it combines with acetyl-CoA, it enters the Krebs cycle and becomes citrate. So a 6-carbon molecule. Okay, so acetyl-CoA combines with oxaloacetate and becomes citrate here. Then it goes through a bunch of chemical reactions around, and we get some things. So I want you to know what we get from the Krebs cycle, but you don't have to know every single intermediate. But you should know that acetyl-CoA enters the Krebs cycle by combining with OAA, or oxaloacetate, to make citrate. So as it goes around, it gives us some ATP, ADP to ATP, and this is through substrate level phosphorylation. So direct. And in one circle of the Krebs cycle, we get 3 of those. We also get NADHs. And we get six of these and 3 of these. Well, with one cycle of the Krebs cycle, we get 3. All right. And then we also get an FADH2. And we get 1 of those. So within this entire cycle, and it's going this way, it's going to run around and go through these little intermediates. And basically what's happening is we're taking citrate and breaking that down, breaking the carbons, 2 of the carbons off of citrate in order to get back to oxaloacetate, which is the 4-carbon molecule. So when we do that, we're going to liberate some NADHs, and we're going to get some ATP and some FADH2. In one cycle, we get 1 ATP. Sorry about that. Okay, so in total, if we look at these 2 reactions, so we have the transition in the transition reaction, we're going to get 2 NADHs, okay. We also got that carbon dioxide, and in the Krebs cycle, make this black. We're going to get, in one turn of the Krebs cycle, we're going to get 1 ATP, 3 NADHs, and 1 FADH2. We also get, since we're breaking off these 2 carbons, we're also going to lose some more carbon dioxide. So in total, we lose 4 more carbon dioxides, and that's where the 6 carbon dioxides come from in that equation that are the waste product here. All right, so there are 2 cycles of the Krebs cycle. So ultimately, in total, we're going to end up with 2 ATP, 6 NADHs, and 2 FADH2. So this is total for the Krebs cycle. And then total with the transition cycle, then we will have 2 ATP, 8 NADHs, and 2 FADH2s. FADH2 there. Okay, so let's put the grand total here. So the grand total in the mitochondria, when pyruvate comes in, we end up with two ATP, 8 NADHs, and 2 FADH2. So that is the grand total of what we get from this second pathway from the Krebs cycle. Okay, and this is important. We have ATP. We've got 2 more ATP. We got 2 ATP from glycolysis. We've got 2 more, so that's good. All right, but what's more notable is we have all of these electron carriers carrying each one of them 2 high energy electrons. So now we can take those electrons and go over to what we call the electron transport chain. So don't forget that we had some electrons left over from glycolysis too. So with glycolysis, if we add the first part of this, then now we have 4 ATP, because we had netted 2 in glycolysis. We've got 2 from the Krebs cycle, so there's 4. We also had 2 NADHs from glycolysis, so now we have 10 NADHs, and then we still have that 2 FADH2. So all of those electron carriers now can go to the electron transport chain. So that's what we'll talk about next, is exactly what's going to happen to these electron carriers.